In the last video, we set up Kafka in a Docker container and broke down how it works. Now it's time to put that knowledge to work. Well, in this video, we are going to build a real-world microservice architecture using NestJS with Kafka communication and multiple services listening and reacting in real time. This is where theory meets practice. And by the end of this video, you will have a fully working event-driven system powered by Kafka. Alright, this is the microservice architecture that we are going to implement in this video. We have the API gateway here, which is a NestJS application, and then we have the Kafka broker, which contains 3 topics here. Then we have 3 microservices here: payment service, order service, and notification service. So the client app calls a REST API from the API gateway to create an order. The API gateway emits a message to the order created topic inside the Kafka broker. As you can see here, the order service is subscribed to the order created topic, which means that it reads the messages from the order created topic. So the order service reads that order created message from the order created topic, and then it processes the order. As you can see, in the same time, the notification service is also subscribed to the order created topic, which means that this message that comes from the API gateway is also read by notification service simultaneously. So it actually sent a notification email, something like your order is placed. Then the order service, after processing the order, emits another message to the process payment topic here in the Kafka broker, which is subscribed by the payment service. It means that the payment service read that message from the process payment topic and actually initiate processing that payment. After the payment is succeeded, the payment service sends another message to the payment succeed topic inside the Kafka broker. As you can see, this topic is subscribed by the notification service, which means that it reads that message from the payment succeed topic and actually send a notification email, something like your payment was successful. Alright, so as you can see, the notification service subscribed simultaneously into 2 topics: order created and payment succeed. Alright, so this is our microservices architecture, and we are going to implement them with NestJS and Kafka. Let's get into the code. Alright guys, I open up a brand new NX Monorepo with Nest preset. As you can see, it only contains an API gateway, which is a completely new application. I did not do anything inside it, and it's completely untouched application. So if you want to know how you can create a monorepo with Nest preset with NX, you can use this script. You can also watch the episode about creating a NX monorepo with NestJS applications. So let's get back to the diagram here. Let's start with the API gateway. As you can see, it should expose a REST API for the client, so the client can call that REST API to create an order. And then the API gateway should send it as a message to the order created topic inside the Kafka brokers. So let's first configure the API gateway application. Alright, I get back to the VS Code and I go to the app module inside the API gateway. Okay. Here we need to register a client module which actually works with Kafka. In order to use the client module, we need to install the NestJS Microservices. So here I open up the terminal and say npm I at nestjs/microservices. Alright, we have an error here, and that's because we need to upgrade the NestJS libraries to the latest versions. So in order to do that, I'm going to use npm check update package to upgrade all the packages inside this monorepo. So first, let me clear this up. First, we need to install that npm i-g ncu, which stands for npm check updates. All right, it's done. And since I have already installed that in my machine, it gets this error: file already exists. It means that it is already installed on my machine. So we can now use that. Now I'm going to say ncu to check the possible updates for our Node.js packages. So let me maximize this terminal. You can see we can update NestJS to the version 11 and all of these packages to their latest version. So now we need to run ncu-u to upgrade the package.json. So just use ncu-u here. It upgrades all the package versions inside the package.json file. And now we need to run a npm install to install new versions. So let me just clear this up and say npm I. All right, it's done. And let me open up the package.json here. Let me close this up. So as you can see now, the NestJS packages are upgraded to the version 11. Okay, now we can install the NestJS Microservices package. So let me clear this up. And I'm going to say npm I at nestjs/microservices. And also, I'm going to just install Kafka.js. All right, now it's done without any error. Now we get back to the app.module here from the API gateway application. Now we can just use the client module to register a client with Kafka communication. So use client module that register and then call the register function. Inside it, we're going to pass a list, and inside the list, we're going to pass an object. First, we need to define a service name. We will need that name when we want to inject this client module into our controllers and other services inside this API application. So here, I'm going to just name it Kafka service. And the better idea is to save it inside a constant and export it from this file. But for now, let's just keep it simple and hardcode it here inside this client module. Next, we need to specify the transport layer. So I'm going to use transport option and set it to transport, which comes from the NestJS/microservices. And then we should set it to Kafka. Okay. Then we need to put the options here. And inside the options, first we need to set the client. And in the client, we need to actually set the brokers. So the brokers is the address of our Kafka servers. Since we have only one server, which is going to be run inside a Docker container with the default port 9092. We're going to use localhost 9092, okay? So we need to actually bind the port 9092 of our local machine to the same port of the Docker container of Kafka. All right, so that's it for the configuring the client module with Kafka transport channel. And now we need to set up Kafka inside a Docker container. In the previous video, I've shown you how you can use a Docker Compose file to set up Kafka inside a Docker container. So just quickly do that again here. Let's create a docker-compose file, .yaml, okay? And since we have completely explained this file in the previous video, I just copy and paste the content from the file that we have created in the previous video. So as you can see, we have two services here, Zookeeper, which is required for management and configuration of Kafka, and then Kafka container itself. And as you can see, we bind the port 9092 of our machine to the port 9092 of the Docker container, which is the default port of the Kafka. Okay, let's save this. And now let's put up the terminal. And here, let's run the Docker container. So I'm going to use docker compose up. All right, so as you can see, it is running without any error. Okay, so let me close the terminal and we're done with the app module here. We have registered the client module with the Kafka service. And now I go to the app controller here and expose a post endpoint, which is a REST API for creating an order by the client. So it is going to be a post request, and then it is going to be something like order, so it will be reachable at /API/order. Okay, we're going to create a method for this endpoint. Just call it create order here, and then we're going to use @body for getting the body from that request, and I'm going to name it order. I'm going to set its type to any, but as you know, the best practice here is to create a DTO for this order, but I'm not going to do that because this makes this video too long. Okay, now inside the create order function, we need to get that order and then pass it to the order created topic inside the Kafka broker. So first we need to inject the Kafka client inside this constructor. So in order to do that, I'm going to use @inject, and then we need to provide the same name that we have set here for the name of the Kafka client. It is Kafka service. So let me just copy that and paste it here. Then it is going to be a private read-only Kafka client, and its type is going to be of type client Kafka. All right, now we can use this service inside the create order endpoint. So here we can just say this Kafka client dot emit, and then we need to put the name of the topic, which is order created. It's the name of the topic inside the Kafka broker. And then we need to put the order data as the body of the message. Okay, that's it for sending this message to the order created topic inside the Kafka broker. Then we can just return object back to the client. Inside it, we can set a message property and say something like order sent to Kafka, and then put the order inside it. All right, that's it for the API gateway application, and we're done it. This application actually works as a producer that sent this message to the Kafka broker. All right, let's save this. And now let me get back to the diagram here. Now we need to create the order service, which actually subscribe to the order created topic. So let's do that. I get back to VS Code and open up the terminal. Let me create another terminal here. And since this is a NX monorepo, we're going to use NX generator to create a brand new NestJS application for us. So here I'm going to use NXG, which stands for generate, and then use the NestJS plugin, which is at nx/nest, the name of the generator, which is app. Actually, this means that we are going to create a new NestJS application, and then we need to put the path of the application. It is going to be inside the apps directory, and then its name is going to be order-microservice. Just use ESLint, and just for testing, as you can see, it immediately creates the application for us. So let me close the API gateway application. Now we have the order microservice and order microservice end-to-end testing application. So here I put up the order microservice here. And the first thing we need to do here is to go to the main.ts file and configure this application to be a microservice application that listens to the Kafka transport channel. So let me close the terminal here, and let me just remove all of these codes here and here. For creating the application, instead of using the create method of the Nest factory, I use the create microservice method here, and we need to pass the microservices options here, then pass the app module, and then after that we need to pass a config object. We need to specify the transport channel. It is going to be on the Kafka channel, so I set it to transport.kafka. Then the options here, set the client, and inside the client we need to set the brokers list, which is the address of the Kafka server. So it is going to be on localhost and then port 9092. And then after the client, we need to set the consumer here. And inside the consumer, we need to set the group ID. So the group ID defines which consumer group this service belongs to. If multiple services, like in our case, order service and notification service, each have a unique group ID, they all receive a copy of the same message. But if you have multiple instances of the same service, let's say we have 3 instances of the order service with the same group ID, Kafka will actually split the messages between them. It means that it actually works as a load balancer, and each message will be processed by only one instance of the order service inside the same consumer group. This is actually perfect for power processing and scalability. So, unique group ID means that each service gets a copy of the same message, but the same group ID means that Kafka balances the load across instances. All right, so make sure to have a unique group ID for each different microservice. So in this case, I'm going to set the group ID to order consumer group. Okay, and then after that, we need to use the app.listen. Don't forget to put the await before it. Now here, the logger should be something like the application is listening to Kafka. Okay. Now the order service is a microservice that uses Kafka as its communication channel. So let's get back to the diagram here. This is the order service, which needs to subscribe to the order created topic. Let's get back to the VS Code, and in order to do that, I go to the app.controller.ts file inside the order microservice, and here we need to create a message pattern for the order created topic. So every message that is sent to the order created topic will be captured by this message pattern endpoint. So here I'm going to use message pattern decorator, which comes from the NestJS Microservices, and then we need to put the name of the topic that we are going to subscribe into it. So it is going to be order created. Okay. Then we need to create a method for it. So I'm going to just name it handle order created. Inside the parameter of this function, I'm going to use the payload decorator, which comes from the NestJS Microservices, and it is used for getting the body of the message from the topic. So it is going to be order, and I'm going to say it's typed to any. As I said, you should use a DTO for this order here. Then here, let's just log something like received the new order. So here, I'm going to use console.log, and here, let me say this is the order service and say something received new order and put the order after that. All right, so that's it for subscribing to the order created topic. Now let me just run this application. So I open up the terminal. In the first terminal, we can use NX run menu to run all the applications simultaneously in just one terminal. But I'm going to just run each of these applications inside a separate terminal so we can see the logs of each microservice inside a separate terminal. So here I'm going to use NX serve API gateway. All right, it's running on the port 3000. Now let's create another terminal and run the order microservice here. NX serve order dash microservice. Okay, as you can see, the application is listening to Kafka. Now let me test the application. So I open up the Insomnia here. So as you can see here, we have a post request to the localhost 3000 and /API and then /order. Okay, in the body of the request, we have a JSON object with order ID and the name of the user. So if I send the request, it actually sends back a message, order sent to Kafka, and put the order back to the client. Now let me get back to the VS Code here. And here in the logs of the order service, you can see received new order, and here is the order 13 and the username here. So this means that our NestJS Microservices architecture is working well without any error so far on the Kafka communication channel. So here, let me get back to the diagram. So far, we have implemented the API gateway. We send the order to the order created topic, and the order service subscribe to the order created topic with the message pattern decorator and reads the messages from this topic. Let's work and complete the order service here. As you can see, it needs to emit a message to the process payment topic. So in order to do that, we need to register a client module of Kafka inside the order service as we have done it in the same way that we have done it inside the API gateway. So let's do that. All right, I get back to the VS Code and I go to the API gateway. I go to the app module of the API gateway and just copy this client module.register function and go to the order microservice and then go to the app module, and we just need to put it here inside the import section. All right, so let's import the client module and transport from the NestJS microservices, and it's done. Now we can use this client module to emit messages to the Kafka broker. So let's get back to the app controller here. We are in the order microservice, and now here, after logging the received new order here, we're going to send a message to the process payment topic. So first here, let me put a comment here. In a real world application, we need to actually process the event before sending the message to the process payment. So here, I'm just put a comment here, simulate processing the order. Okay. After that, we need to use the Kafka client to send the message to the Kafka broker. So we just need to use the inject decorator here and put the same name that we have used to register the Kafka client module. So I copy that, paste it here, and then in order to speed up the process, let me just copy private read only Kafka client and set its type to the client Kafka. It is the same as we've done it inside the API gateway controller. Okay, now we can use this client, the Kafka client, and emit. This time, we're going to send it to process payment topic and then put the order as the body of the message. So let me get back to the diagram here. We've done the order service, and now we need to create the payment application, which actually needs to subscribe to the process payment. So let's do that. Okay, I get back to the VS Code and let me create a new terminal here. And let's create a new application for the payment microservice. So I use NX generator here again, NXG at NX/nest, and then app is going to be inside the apps and then the name is going to be payments dash microservice. Okay, it's done. And now let me go to the main.ts file inside the order microservice and then just copy this lines here. Actually, let me just copy the whole file because it is going to be the same, and get back to the payment microservice and open up the main.ts file inside it. Okay, let me just copy all of these codes here. As you can see, we are creating a microservice with Kafka transport. We set the broker's address to the localhost 9092, and all we need to do here is to change the group ID. Okay, I'm gonna just set it to payments consumer groups, and here in the logger section, I'm gonna say payment microservice is listening to Kafka. That's it. And then we need to create a message pattern which subscribes to the process payment topic. So I go to the apps controller here, and I'm going to use a message pattern here. The name of the topic is going to be process dash payment. And then we need to put a method for it. It is going to be process payment. Use the add payload for getting the payload from the message. And then we're going to get the data from the body of the message and set its type to any here. And then we just need to process the payment. But here I'm going to just put a message inside the console from payment service and say payment in process and pass the data after that. Okay. In the real world application, you need to handle the payment processing here. But let me just skip that and just use this console.log here. Okay. So let's run this new application. So nx serve payment dash microservice. All right, so the payment microservice is listening to Kafka. Now let's get back to Insomnia and send the request to the API gateway. Okay, now let me get back to the application. You can see here inside the payment service, the payment in process, and get the order and the name of the user. Also, if I go back to the order microservice, you can see here we have the message order service, received new order. This is the order ID, and this is the name of the user, which is the same as this object inside the payment service. All right, now let's get back to the diagram here, and we have completed this section here. We subscribe to the payment process topic in the payment service. And now after getting the process payment service, we need to emit a new message to the payment succeed topic inside the Kafka broker. So let's do that. Okay, I get back to the VS Code, and in order to send a message to the payment succeed topic, we just need to register a client module for the Kafka service and then inject it to this controller and then use the emit function from that service. So it is the same as the order service. So I get back to the app module of the order service and just copy this lines of code, which actually register a client module for the Kafka service, and get back to the app module of the payment microservice. And inside the import section, I just copy this and let me import the client module and transport from the NestJS microservice. That's it. And now let me get back to the controller of the order microservice and just copy this lines for injecting the Kafka service to the controller, and get back to the controller of the payment service and then just inject it here for the controller. Okay, it is all the same with the order service. Now after delogging the payment in process, we just need to use this .kafka client.emit function and send a message to the payment succeed topic, and then put the data in the body of the message. That's it. And if I get back to the diagram, you can see we have completed the payment service communications. Now we need to create the notification service, which needs to subscribe into two topics, the order created and also payment succeed topics. So let's do that. Okay, I'll get back to the VS Code and let's create a new terminal here and then use the NX generator to create the notification service. So nxg at nx/nest app, and then put the name of the application. It is going to be inside the apps directory, and then its name is notification microservice. Okay, let's do that. It's done. And first we need to set up a microservice inside the notification service. So I go to the order service here, it is the same as the order service and payment service. So I open up the order microservice and just copy all of the code here inside the main.ts file, get back to the notification microservice, go to the main.ts file, and then replace the code with the code that we have copied from the order microservice main.ts file. We just create a microservice with the Kafka transport communication channel. We set the broker's address here, and for the group ID, we need to use a different group ID here. It is going to be notification consumer groups. Okay, that's it. And then we need to go to the app controller file and subscribe to the topics. So let's go back to diagram. We need to subscribe to the payment succeed and order created topics. Get back here and then use a message pattern here. At message pattern, the name of the topics is going to be order created, and let's create a function for that. Its name is going to be send order created notification. Use the payload decorator here and get the data out of the message body. Set the data type to any. As I said several times here, best practices here is to use DTO here for the typing. Okay. Here we can use the node mailer to create a notification email, but this is beyond the scope of this video. So just put a console.log message here from notification service sending order created and put the data here. Okay, let's just copy that and create a message pattern for the payment succeed. But before doing that, I think the name of the topic is order created. So let's fix that and then create another message pattern. This is going to be for payment succeed, payment dash succeed. Okay, change the name of the method here. It is going to be send payment succeed notification. Okay, let me change the console.log here. Notification service sending payment succeed email. Okay, let's save this. And I think we're done with the notification microservice. So let me get back here. Yeah, it does not send any message to the Kafka broker. You just need to subscribe to these two topics that we have just done now. Okay, let me get back here and run the notification microservice. So nx serve notification microservice. All right, the application is running. So let's get back to the Insomnia and send another request to the API gateway. This time the username is Evelyn, I think. Let's get back to the VS Code here. And here we have the sending order created with this name, but we don't see the payment succeed. I think we have misspelled the name of the topic here. So this is the payment succeed. And let's go to the payment microservice and go to the controller here. Payment succeed. Let me just copy that, get back to the notification microservice, and let me just paste it here. I think it was the same. All right, guys, I just paused the video and check out the whole application to find the problem. And the problem was that because of the app module file inside the payment microservice, this file has not been saved, so the client module didn't register inside this application. So now let me open up the Insomnia again and send a request again. This is the user Eleanor, and let me get back to the notification microservice. You can see the first log for order created with the same username and the second message for payment succeed with the same username. So if I get back to the order microservice, you can see we've got new order with the same username, and then go to the payment microservice. You can see the payment in process with the same username. So the application is working without any error. All right, now let me show you the function of the group ID in action. Here, as you can see, the notification service and order service subscribe to the same order created. They must have different group ID to get a copy of each message inside the order created topic. Otherwise, if they have a same group ID, only one of them get the message from the order created topic. So now let me get back to the order service and go to the main.ts file. You can see we have the group ID here. Let me just copy this group ID and get back to the notification service. So let me find that. It's here. Okay. And then just put the group ID as the same as the order microservice. So let's save this, and the application is running. Okay. Now let me just send the request again to the application with the name Arden. get back here, as you can see, the notification service get the message with the name user Arden, but the order service doesn't get that message. And that's because the order service and notification service, they both have the same group ID. So the Kafka sent the message only to one of these two services. So in order to fix that, let me get back to the notification service and just change back the group ID to the notification consumer group. Let's save this. And now let's get back to the Insomnia and send the request again. Now we've got the message from the order created and also payment succeed with the same username. If I get back to the order microservice, you can see we've got a new order with the same username. This is why we need to have a unique group ID for each independent service. Now let me turn off the notification service and then send a request to the application, okay, with the name Brooke. And here, let me get back to the order service. We've got a new service with the name Brooke. And here in the payment microservice, we've got the payment in process with the Brooke, but the notification service is down. But as soon as the application goes up again, we immediately get that messages from the Kafka broker, and the application send the emails to the user. As you can see, the name of Brooke here is the same as the last request to the application. So as you can see, Kafka is a great tool for creating a reliable and failure-resilient microservice architecture. This is a great tool, and actually you can make sure if one of your services goes down, the whole application does not go down. The other services work without any interrupt, and as soon as the broken service goes up again, it starts processing the messages that have been stored in the Kafka broker topics. So yeah, that's it for this video. If you found this video helpful, please hit the like button to give me more energy to create more episodes of this course for you, and subscribe to the channel to get informed about the next episode of this course. Your likes and subscription doesn't cost you anything, but it really matters to me. Thanks for your support. Have a nice time and stay tuned for the next episode of this course. Bye-bye.